If you're scoring below 700 or running out of time in the math section, you're not taking full advantage of the Desmos calculator. In this video, I'll cover everything you should use Desmos for on the SAT, and I will also discuss some times when using Desmos is not the best choice. And let's actually start this with what I think Desmos is used best for, which is solving systems of equations quickly. Take this question, for example. Of course, if we're trying to find any sort of intersection and they give us two equations, especially if they're both set to y, it's pretty easy to just set them equal to each other. So we would have like x plus 3 equals 2x minus 6. Then we could subtract x from the left side and the right side. And then we could also add 6 to both sides. So then we get 9 equals x, which is pretty fast. But if you don't know what to do, or if it's straight up faster, Desmos is a great option here. If we open up Desmos, we just have to type in our equations here. So we had y equals x plus 3. Then the other one was y equals 2x minus 6. And as long as you've got your mouse, you can just kind of drag over to the intersection point. It's going to automatically make it very prominent and show you what the points are. And boom, we know our answer is 9 right there. So Desmos could definitely be a faster option. And if you don't know how to deal with systems of equations, it's the only option and a really easy option. By the way, make sure whenever you're practicing and you're using Desmos outside of Bluebook that you actually choose the correct version of Desmos. You go to desmos.com/practice and then you choose your assessment and then you just type in SAT. And now you know for a fact that you're using the actual College Board approved version that you will be using on test day. Let's look at another one here. This one is actually not even immediately obvious that it's a system of equations, but as you start reading, you can kind of figure it out because systems of equations are going to be usually two different categories of things. So for example, we've got R miles versus B miles, right? Biked miles versus ran miles. And each of those is going to have its own value attached to it. In this case, we've got 10 miles per hour if you're biking, 5 miles per hour if you're running. Another similar setup might be something like, you're buying a large ice cream or a small ice cream. You have two different price points. Anyway, that's all to say, when we see these different values assigned to the same type of thing, we know that we have a system of equations. And the first thing we need to do is actually write this out, regardless of whether we're going to use Desmos or not. So because we have R miles at 5 miles per hour, we could say like 5R basically. So each R is going to get 5 miles per hour. But because I'm planning on using Desmos, I'm actually going to just say that this is X. X is going to be my running miles, right? So I'll say 5X, and then we know that our biked miles are 10 miles per hour. So I'll make that my Y. And the reason I'm choosing X and Y is because Desmos is going to want a value of a constant if you choose a constant other than X or Y. So then plus 10Y, and then it says she ran and biked a total of 200 miles. So I know if I add all of those together, we're going to ultimately get 200. So that is an equation right there. And then we get another equation here. It says, and she biked for twice as many hours as she ran. So if her biking hours are Y, that would mean that Y is equal to 2 X's, right? Twice the number of running miles. So now I have my system of equations. And from here, you could use substitution, you could use elimination. I would argue that whether or not you know how to use substitution or elimination, I think Desmos is going to be faster because you're probably going to want to end up using Desmos to do your multiplication or division or whatever anyway. So might as well just put the equations in and let it do all the work for you, right? So let me pull up Desmos here, and same thing, we're just going to put our equations in. We've got 5x plus 10y equals 200, and then we've got y equals 2x. All right, intersection point is showing up right here. Intersection point is 816, 816. So let's write that down real quick. X is 8, y is 16. All right, and then let's make sure that we know what we're answering here. It says, what is the total number of miles that Morgan biked? So remember, biked was y, so y is 16, but remember, that's not the total number of miles that Morgan biked. That's simply the value of y. The total number of miles that Morgan biked was 10y, remember? So what's 16 times 10? 160. And our answer is D. All right, one more example of systems of equations here, because I want to show you systems of equations, it works even when it looks like it's not going to work. So on this one, you can kind of tell from the answer choices that it's pointing you towards the quadratic equation, right? And because of that, you might feel like, how am I supposed to use Desmos for this? But trust me, we can use Desmos for this. Let's do it. All we're going to do is what we normally do, plug these equations into Desmos. So let me pull it up. First one was x minus y equals 1. And then the other one was x plus y equals x squared. And I'm using my little caret, so I don't have to use the keypad down here. Get used to shortcuts. There's another tip for you. And if you want a separate video on those shortcuts, let me know. Maybe I can make one for you. In the meantime, I actually decided to just hook you up with a free cheat sheet. So look in the description of this video. There's a link and you'll get a cheat sheet with all of the keyboard shortcuts on Desmos that you're actually going to end up using on the SAT. -3. So we've got our systems of equations, right? And the question was asking me, which ordered pair is a solution to the system of equations? Okay, so what's the issue here? Well, if we go and we drag down to our intersections, we've got a couple of them, but neither of them are in the form that we're looking for, right? We're looking for 1 plus the square root of 3 and the square root of 3 and stuff like that. So what are we supposed to do? Well, it's actually not that hard. We can just plug in our answer choices and see what they look like as decimals, and then we can match up from there. So the first one is the square root of 3 and 1 plus the square root of 3. Basically, we just need to know what the square root of 3 is, and then we could add 1 to it, because that's pretty easy to do in your head, right? So what is the value of the square root of 3? Let's see. Another shortcut, SQRT, boom. So square root of 3 is equal to 1.7. And the answer A said that our y value on one of these was the square root of 3. Obviously, it's not going to be negative, so let me look at this positive one. And what do you know? 1.732. So that is, in fact, a y value. And then the x value is supposed to be 1 plus the square root of 3. Well, if it's 1.732 and 2.732, that is 1 plus the square root of 3. So we got lucky. It was choice A, but if it wasn't choice A, we would eliminate. We would try out choice B, so on and so forth, and we would pretty quickly get our answer using Desmos. But yeah, our answer is A for this one. Desmos is also great for just choosing equations. Take this question for example. It says, line T has a slope of -1/3 and passes through this point. Which equation defines line T? So in this case, we're actually trying to choose which equation lines up with this line that's being described. Before we did anything with Desmos, I would probably go ahead and just eliminate choices A and B. You are going to have some knowledge about slope. Basically, y equals mx plus b is our slope-intercept form, and m is the slope. So choices C and D both have -1/3. Like it says -x/3, but basically that's the same thing as -1/3x, right? If you multiply -1 3 times x, you get -x/3. So those two have the right slope. So I already know it's between those two. And then it's just a matter of, is the y-intercept going to be 10 or is the y-intercept going to be 13? So for that, I can use Desmos. And the way I'm going to know what my right answer is, it's going to be the one that goes through 0.910, right? So let's try out answer choice C first. Choice C said y equals -x/3 plus 10. And we're supposed to be checking to see if 0.910 is on the graph, right? So we need to scroll over a little bit. We need to find 9. We could even zoom in so that 9 becomes a lot more visible. And then we're scrolling up and we look here. Do we have 9, 10? No, we have 9, 7. And the scrolling and the moving around is super easy only because I have a mouse. Oh yeah, and another bonus tip, use a frickin' mouse. If you're not using a frickin' mouse, what are you doing with your life? I'm wearing my glasses right now because I'm very serious about this. This little tool is gonna make you so much faster. It's gonna make everything so much easier. So I don't wanna hear any excuses. Use a mouse. Anyway, so we know that that doesn't work. So from there, we could just eliminate C, and we know that D is the correct answer. But if you're feeling nervous, you could obviously go back to Desmos, change that y-intercept to 13 to match answer D. And then we go to 9, scroll up, and indeed that point 9, 10 does exist. So we're all good there. Something else that Desmos can do that a lot of students don't know is actually deal with those tricky constants questions. Now, to be clear, these constants questions come in a variety of forms. They could show up on a lot of different types of math problems. The ones that you can solve with Desmos are going to involve graphing or the XY plane in some way or another. So this one, for example, we say, how many times does the graph? So we know that we're dealing with graphs, right? Anyway, this is interesting because we actually have two different constants here. So how the heck is Desmos supposed to work? Well, let's take a look. Let's just open it up and we're going to put that equation in, y equals ax squared minus c. And you're going to notice when you do this that Desmos asks you if you want to add a slider. The answer to this question should always be yes. And I'll go ahead and add a slider to both. We'll take a look at this in a second. But first, what's the rest of the question here? So it says, how many times does the graph of the equation above intersect the graph of the equation y equals a plus c? Well, let's add that one. So we're going to add y equals a plus c. And let's go ahead and zoom in here because I can't see what's going on. If we just go based off of this, where it's automatically choosing 1 and 1, we have 2 intersections. And that is indeed the answer. So if we go back, it specifies that A and C are both positive constants. And really, no matter what happens, as long as these are positive, so if I change A to like, I don't know, 4.4, we still see 2 intersections, right? If I change C to 10, we still see 2 intersections, right? So you can see that no matter what happens, we're going to get 2 intersections. And to be clear, these sliders here, you just get to basically choose whatever value you want. Sliding around is fun and really helpful in certain circumstances that I'll show you in a second, but you could also just like put in a value, right? You could just say A equals, 999. It was 2 intersections, so our answer for this one is going to be C, 2. Here's another example of a question with a constant in it. This time it's saying the equation has no real solutions. So for this one, we do need the upfront knowledge that no solutions means no crossing over the x-axis, because a solution to a quadratic, we can tell that this is a quadratic here. We've got x squared is going to be when the quadratic crosses through the x-axis. So basically, we want to plot this out, and then we want to choose the answer that shows the quadratic not crossing the x-axis at all. So I'll open up Desmos. This time we've got 2x squared minus 4x equals t. And then for whatever reason, it's not giving me the slider option here. It's just getting mad at me. But what I can do is I can say t equals, and then I can put in my answer choices. So the first one was -3. Boom. And if we look, I'm not seeing any crossing of the x-axis here. If I zoom back, but I'm not seeing it crossing over the x-axis, which makes me think, oh, this is probably our answer, right? Another option B was -1. So if I go to -1, we can see it crosses the x-axis twice. Another answer was 1. We can see it crosses the x-axis twice. The other answer was 3. So you can see it crosses the x-axis twice. So that answer, -3, where it doesn't cross over the x-axis at all, was our correct answer. So choice A. All right. And I wanted to show you just one more where I feel like the slide the slider comes in really handy. So this one is labeled hard. We've got a constant. In this case, it's another quadratic, and it's asking us, the value of C when the equation has one solution. Well, as we already discussed, a solution is when it crosses the x-axis, right? So if you're familiar with quadratics, you should know that the only time you're going to get one solution is basically if the vertex is touching the x-axis. So that's what we're going to be looking for when we graph this out. So same thing, we're going to get Desmos out. We're going to put in our equation. This time we have negative 16x squared minus 8x plus c. And there it is, it wants us to add slider C. So this is where I think it really comes in handy, because as we move it around, you can see the graph is also moving around, which makes it really easy to spot when we get our vertex touching the x-axis, right? So I'm going to move it. Okay, looks like right there it's happening. And if we zoom in, sure enough, oh, boom, negative 0.250. So it's just touching the x-axis there, and that was a value of -1. So our answer, just like that, is going to be -1. Another great use for Desmos is just finding intercepts. So here's an example where we're looking for an intercept. Now, for these types of questions, if you know the trick, the rule, which is basically x-intercept means y equals 0 and y-intercept means x equals 0, some of these are going to be easier and faster without Desmos. But that's assuming that you know the trick. What's really cool is if you don't know the trick, we could just plug this in real quick. So I'm going to plug in my equation. And a pro tip here, anytime you've got a function, you could definitely put in the function if you wanted. You could put f of x, f of x equals 7x minus 84. So it's going to recognize that as a line, but you could also just put y equals, because on the SAT, f of x is always going to be the same thing as y. So just for simplicity's sake, I'll have y equals. And then it was asking the x-intercept. So that's where it touches the x-axis. We go here, and that's 12, 0, right? So just like that, our answer is A, 12, 0. And that was pretty fast, but if you also know that the x-intercept is when y equals 0, we could pretty quickly say, 0 equals 7x minus 84. Move the 84 over, 84 equals 7x, and then divide by 7, 84 divided by 7 is 12. And I just realized I circled -12 instead of +12. It should be choice D here, not choice A. My bad. But yeah, that one's kind of a toss-up, depending on how fast you are at doing the arithmetic there. Here's another example where we're looking for an intercept. This time we're looking for the y-intercept. So let's start by saying we don't know what's going on here, right? Because we've got this crazy equation. It's looking scary. We have an x as an exponent. So, maybe we're freaking out. But no need to freak out, right? We've got Desmos. Let's pull up Desmos and throw that crazy equation in. By the way, as we continue through this video, if you want to start practicing and trying to use Desmos, you've pretty much got it down, right? What do? We put the equations into Desmos and kind of go from there. So feel free to pause the video and try these on your own first as we move through the rest of the video. But what was that equation we were looking at? It was f of x, so I'm just going to say y equals, and then we had in parentheses -8. Then we had in parentheses 2, and then raised to the x power, terrifying, I know, plus 22. And then it was asking us about the y-intercept. Y-intercept is, oh, that's the x-intercept. I'm like, why are they giving me a weird, okay, y-intercept is 0, 14. So just like that, our answer is A. And this was rated hard, by the way, difficulty level 3. I don't think so, not with Desmos. But here's the cool thing. If you have the ninja skills and actually remember that the y-intercept is when x equals 0, and you know how exponents work, this is even faster without Desmos, I think, because basically this is 0. Anything to the 0th power is 1. So then we have -8 plus 22. 22 minus 8 is 14. Boom, answer's A, even faster than Desmos if you got the skills required. Another great trick that Desmos can do is actually to help you boop the like button on this video. For real though, if you're enjoying the video, please give the like button a boop for me. But what I was gonna say is Desmos is really good at finding the minimum or maximum of a parabola. So this is a great example, but for half a second here, let's just talk and clarify what a minimum and a maximum is. So if you've got a graph and you're looking at a parabola is either going to be a happy face or a sad face, right? We've got this sort of U shape. It's either right side up or upside down. If we're looking for a minimum, that is the vertex, because right here, as you can see, it can never go lower than that. And you can see that the minimum is by definition the Y value, because these guys are going to keep going in these directions for infinity, so they don't really have any limit. Same thing with a maximum. If we're looking at this guy, the vertex is going to be our maximum because it's never going to go higher than that point. Again, the Y value is going to be the maximum. So whenever you see minimum or maximum and it's a quadratic, aka a parabola, just know that you're looking for the vertex and specifically the Y value of the vertex. Now that said, this says for what value of X does it reach its minimum? So in this case, we're actually looking for the X coordinate of the vertex. Anyway, what are we going to do? You've guessed it. We're going to plug this into Desmos. So let's do that. And the equation was f of x. Again, I'm just going to make that y equals x minus 10 times x plus 13. Going to zoom out and zoom in. Actually, I've got a scroller on my mouse, so I can just scroll. And it looks like our vertex is here. And the x value is -1.5. Now, -1.5 is obviously -3/2, but another cool feature here, because you're going to notice that the answer choices are in fraction form. If you did -1.5, this little button right here, boom, -3/2. So if you ever need to convert to fractions, that's another cool thing that Desmos can do. A little bonus tip for you. So -3/2 is choice D. Our answer is choice D. And this was another hard question. I don't think it's actually that hard if you're using Desmos, which is fantastic. I wanted to show you one more of these because this one actually looks a little bit harder. And we've got another function, but in this case, they're throwing like a function within a function. They've got this f of x, but then they've got this g of x where it's like f of x plus 5. And then they're asking for the minimum again. So it's kind of wild. At least it looks kind of wild. And if you know how to do like, -b/2a to get your x coordinate of a vertex, which is, essentially what we're asking for, you could do that. But think about it for a second. What are we going to have to do? We're going to have to plug this in for every instance of x. Things are going to get crazy, right? So instead, what we're going to do is we're going to use Desmos. But let's talk about this function within a function for just half a second here. If it says f of x plus 5, all that means is in every case of x in our equation here, we're going to plug in x plus 5 instead. And I'll show you what that looks like in Desmos. So instead of 4x squared, we're going to have 4x plus 5 squared. And then instead of plus 64x, we're going to have plus 64x plus 5. And then the last part of it was plus 262. That doesn't change because there's no instance of x, right? So that's what our equation looks like. And we're looking again for the vertex. You can always hit the little home button here if you've been screwing around like I have. And then boom, there's a vertex. There's our minimum. Hover over it. -13 is our answer. So that is choice A, -13. Here's another trick that Desmos can do that a lot of students don't realize. It can actually help you with inequalities. I would encourage you to definitely try this one on your own first. You can probably guess what we're going to do, but let's go ahead and get into it. So yeah, we're just going to plug these inequalities in. So let's open up Desmos. So the first one was y is less than or equal to x. And if you hit y and then you hit the actual less than sign and then you hit the equal sign together, I mean, they're merging together. So I actually just typed the less than caret and then equal, and then they merge. So that's how you do that without pulling up the keyboard here. Definitely encourage you to get used to doing that because it's, at the end of the day, it's going to be faster, and shaving off a few seconds is always a good thing. Anyway, y is less than or equal to x. And then our other one was y is less than or equal to negative x. Cool. And it was asking us for the solution to the inequalities. Now, normally a solution is where you have lines touching, but in the case of inequalities, a solution is just going to be where you have both colors merging. So you can see like everything that's shaded blue is that blue equation, everything that's shaded red is that red equation, and where they cross over down here, this is our entire set of solutions. So looking at our answer choices again, basically, we just want to look and say which one of these lives in that area. And you could eyeball it and probably be just fine. But if you want to get really fancy, you could also put in each point. And I'll do that just to demonstrate. So the first one was 1, 0. Oh, it wants the parentheses. I forgot. You got to give it 1, 0. You could even label it so it kind of pops up for you. We had negative 1, 0. We had 0, 1. And then we had 0, negative 1. All right. And you can see that the only one that actually exists in this area we're looking at is the 0, negative 1, the red one, which was choice D. So our answer in this case is going to be choice D. Another trick that Desmos can do that, again, a lot of students don't know is actually solving single variable equations. And this is especially helpful when you've got those, harder or trickier looking single variable equations. All right, so this is where things get really fun because for sure, I would say the majority of students I've worked with do not realize that you can use Desmos on these single variable equations. In this case, we've got one variable, t, right? So there's no, this could basically just be x. So we don't have a y value, we just have this t value. That said, I'm gonna treat t as x. And when we are dealing with single variable equations, we actually can just set it up as two separate equations, and we're going to add y. So basically all you have to do is you take your left side and you say y equals my left side. So in this case, it would be y equals 5t plus 3, so I'll change it to x, 5x plus 3, and minus 7x plus 3. And then my other equation would be y equals the right side, so y equals 38. And that's what I'm going to put into Desmos. Sorry about my sloppy writing, by the way. So Desmos, hello, my dear friend. That was y equals 5x plus 3 minus 7x plus 3, and then y equals 38. And you can see now it's giving us an option to change y if we wanted to, which is kind of fun. Anyway, we know y equals 38, so we'll jump up to 38, and we'll see that line there. And then our solution is negative 22, 38. What was it asking again? The value of t. Remember, t was x, so if x was negative 22, right? Negative 22, that means t is negative 22. So our answer is negative 22. So that question was, whatever. Not the easiest single variable question, but not super hard. Now this single variable equation, on the other hand, I would argue looks a little bit scarier, right? We have x under a root. Like, this doesn't look like it's going to be fun to deal with. And then we have to choose a solution set. So like possibly more than one answer is going to work. Anyway, just remember what I said. We're going to say y equals the left side. In this case, square root of 2x plus 6. At least this time they're using x, so we don't have to change it. Plus 4. And then the other one would be y equals the right side, x plus 3. So that's what we're going to put into Desmos. So again, y equals, and remember SQRT for square root, 2x plus 6. If you hit the right arrow, boom, then you can just say plus 4 to get out of your little root there. And then the other one, oh yeah, down arrow, by the way. Keyboards, mice, super important. Y equals x plus 3. Cool. So those are my two equations. Let's go home real quick. Hello, friends. And then we're supposed to do the solution set, and it was just X, remember? So we don't care about Y. So it looks like there's only one solution, and that solution is 5. So if we go to our answer choices, sure enough, 5, choice B is our answer. Desmos is also great for dealing with number of solutions questions. And I said this before, but try pausing this video right now, getting out that version of Desmos and trying this one on your own first. Because at this point, you have what it takes to solve these using Desmos. We're really just recycling what we've already been through, at least for this problem. But speaking of which, this one is obviously, like I just mentioned, how many solutions. We've already talked about how number of solutions is either going to be like when they touch, if it's a system of equations, or if we have some sort of a quadratic, like it seems we do here, then it's going to be how many times do we cross the x-axis. So let's put in this equation, x minus 1 squared equals -4. Ooh, actually, we could use the trick that we just talked about, right? Because we technically don't have a y, so we could treat this like a single variable equation where we say y equals x minus 1 squared, and we could say y equals -4. And in that case, the number of solutions is going to be the number of times that these two equations touch. So let's do it that way, just to kind of building off of what we were just doing. So open up Desmos, y equals x minus 1 squared, y equals -4. So number of solutions, 0. The line is down here, the parabola's up here. They're never going to touch, so number of solutions would be 0. Our answer is D, the power of Desmos. Another crazy thing, at least I think it's kind of crazy, that Desmos can do is it can actually help you to evaluate functions straight up. Let me show you. And I know what you're thinking here. That's too good to be true, but it's not too good to be true. Desmos can indeed evaluate functions. So this is the one case, if you're evaluating a function, basically it's giving us a function and then it's talking about some other stuff that happens if we plug in different values. This is the one case where I would recommend using f of x. So we're going to put this in exactly as it appears, including f of x. So pull up Desmos here. F of x equals x plus 7. And then if you just highlight this and hit the slash sign, it'll divided by 4. So that's our function. And then it was asking us, what is the value of f of 9 minus f of 1? What do we have to do here? It's going to blow your mind. Watch this. F of 9 minus f of 1. 2. It's just going to give us the answer. That's what's up with Desmos. So the answer is 2, which means the answer is B. And yeah, Desmos can do that. You can also use Desmos for equivalent expression problems. So with equivalent expressions, this is definitely territory where some of you are going to be super comfortable and you can solve them quickly without Desmos. But again, if you don't know how to solve them, Desmos is just such a great option. And even if you do know how to solve them, I would say some of these are going to be faster with Desmos. This one in particular, I think, is faster without Desmos, but let me just show you basically what you want to do with equivalent expressions. You want to put in your original expression, obviously. So let's start by doing that. X squared minus 5. And then all we have to do to find an equivalent expression is plug in our answer choices. And the answer choice is going to create the same exact graph as the first one here, right? So I'll let you take a look here. If you want to try and plug these in and do it on your own first, but I'm going to plug these in now. So we had x plus the square root of 5 squared. So let's get that in. X plus the sqrt. Then that whole thing was squared. And you can see that that is not the same graph. And then the other one was x minus, so we could just replace this. That's also not the same. The other one, choice C, was x plus root 5 times x minus root 5. And here I can copy and paste. I know that I tried copying and pasting in Blue Book, and for whatever reason, even though this is the College Board official version, I don't know if it actually works in Blue Book, just as a little caveat there. But Oh, wait, hold on. It wasn't supposed to be squared. It was supposed to be x plus the square root of 5 times x minus the square root of 5. And you can see this purple graph is the same as this green graph when we turn it back on. Yeah, so they're one and the same, which means choice C, the one that I just plugged in, is our answer. Now, this one, I would argue, is a lot faster if you know that this is a difference of squares, right? Because a difference of squares is we have x squared, and then it's going to be x plus the square root of this times x minus the square root of this. So in this case, it would be x plus the square root of 5 times x minus the square root of 5, which again is choice C. So that one should happen in about 2 seconds without Desmos if you know what you're doing. But if you don't know what you're doing, you might skip it and you might just never get the right answer. So good on you, Desmos. Now for a hard equivalent expressions problem like this one, it's really a toss-up. I know how to do this without Desmos, but it's hard to say which one would be faster. Let's just go through both real quick. So this is definitely a lot more complicated than the last one, so let's unpack it for a second. We know that ultimately we're going to have f of x divided by g of x. We also know that x is going to be greater than 3. That's not usually going to come into play in the Desmos world, but essentially we're going to have this, which is f of x, divided by this, which is g of x. So I would actually just do that in Desmos. So that's what I'm going to do. So we open up Desmos. We had x to the third minus 9x. Highlight that. Divided by x squared minus 2x minus 3. Okay. And then we're going to do the same thing that we did last time where we plug in our answer choices. So if you want to take a look at those and try it on your own first, there they are. But let's go ahead and do it. So the first one was 1 divided by x plus 1. And we can see that that's different. And with these, it's always going to be easy because there's some sort of consistency. Like for this one, all of the denominators are x plus 1, so we just have to change the numerator. Choice B was x plus 3 in the numerator. We can also see that's different. Choice C was x times x minus 3. X times x minus 3, also different. It's kind of a weird looking one. And then choice D, which we know by default is our correct answer, was x times x plus 3. And you see it disappears because it's the same. We can turn this off just to double check, and we can see that they're the same, right? Pretty quick. Like, honestly, I'm thinking Desmos. Oh, it's hard to say because we know our choice is choice D because of that. But let's go through what it would look like without Desmos, just for those of you who know how to solve this without it. Because here we basically have this difference of squares, except for instead of a difference of squares, we're adding an extra x to it, basically. So if this was just x squared minus 9, we would have x plus the square root of 9, aka x plus 3, times x minus the square root of 9, aka x minus 3. But then we know that we're actually doing x to the third, and it's going to be 9x. So basically, there's just an x on the outside of all this. And then our bottom one, this is just a quadratic that we can see if we factor, we want to multiply to -3 and we want to add to -2. So what would that be? Basically, it would be x minus 3 times x plus 1. -3 times 1 is -3. And then 1 minus 3 is -2. So that's how it factors. And then from there, we can eliminate x minus 3. Goodbye, goodbye. And then that ends up matching choice D. So yeah, it's hard to say which one of those is going to take longer. Obviously, as I'm explaining, that version takes longer. But when you're doing it quickly by yourself and you're not trying to explain to somebody in a YouTube video, it might be faster. So it's really up to you. Desmos is also fantastic for circle graphing questions, especially if you're not super comfortable with the circle equation. And this definitely falls into the same category of, tricks we've already learned at this point. I've shown you everything you need to do with Desmos, basically. So pause the video, try this one on your own first, but let's take a look. So in this case, we don't have a line or a parabola, we have a circle. And If you know the circle equation and you recognize this form, you might think, oh, well, I have to do completing the square on the left side, and then I convert it into the normal circle formula, which is going to be x minus h squared plus y minus k squared equals r squared. And then I know that the center of my circle is hk, because it is asking us for the center of the circle. And that's all well and good. But we could also just use Desmos. So let's plug this into Desmos. So let's put in our equation. We had x squared plus 20x plus y squared plus 16y. Oh, sorry, equals negative 20. It's like, what's going on? So there's our circle, and we'll zoom out a little bit here. And annoyingly, we don't actually get the center of the circle as a point, but what we can do is we can go to the very top, because that's going to show up, and we know we have negative 10, 4, and then the bottom we have negative 10, negative 20. So how do we take that to get the center of our circle? Well, we know it's negative 10. So for this one, we could actually just take a look and eliminate everything that doesn't have negative 10, and then answer choice B works. But let's say that we had two answers that had negative 10. Then what would we do? Well, we take our y values, 4 and negative 20, and we basically just need to find the midpoint, right? And how do we get the midpoint? We add them together and divide by 2. So negative 20 plus 4 is negative 16. Negative 16 divided by 2 is negative 8. And indeed, negative 8 was the y-coordinate, right? So that's how you would do it. Now this one, if you know circles really well, you can actually get your answer without Desmos in a matter of seconds. Because like I was saying, what you do with the left side here is you complete the square. And when you complete the square, basically you have to take half of this coefficient in front of x and then square it. So basically it becomes like x plus 10 squared. And then same thing over here, it would become y plus 8 squared. And there's more to it because we have to add stuff to the right side. But if we're just looking for the center of the circle, we actually know that the left side is going to look like this. And then we just follow the formula. So then we have negative 10 and negative 8. Because remember, it's minus h and minus k. So we get our answer in literally like 3 seconds if you know what you're looking at. And if that doesn't speak to you, I'm definitely skipping over a lot if you don't know what completing the square is, so just forget about it. The point of this video is Desmos makes things super easy, so be excited, be happy, be well. Now, one of the things that a lot of tutors like to show off is that Desmos can create tables, and that's certainly true, but most of the time I have found a student will actually complete a problem faster by not using Desmos. So while it is possible to create tables using Desmos, more often than not, those questions are asking about y-intercept or slope, which involves an additional process that just takes too much time in my opinion. The same thing goes for things like mean and median. You can find those using Desmos, but those really basic questions are usually solved faster just by hand. And while those uses might not be the best way to boost your score on the SAT, this video right here actually covers 7 additional hacks that you can use to boost your score quickly and with minimal effort.